Welcome back to my class in Algebra. Today we will study how to solve rational equation. We know that a rational expression is an algebraic expression that is a ratio of two expressions. Some examples of rational equations are the following. Number 1, 5 over y minus 1 over 3 equals 1 over y. This equation is a rational equation because it contains rational expressions. 1 over y is a rational expression because it is the ratio of a constant 1 and a monomial y. A monomial y is an algebraic expression. Although negative 1 over 3 is a constant, it is a ratio of two integers, 1 and 3. 5 over y is a rational expression because it is a ratio of 5, constant 5, and a monomial y. Number 2, 2 minus 1 over m times quantity m plus 1 equals 3 over m plus 1. This is again an example of rational equation because it is an equation and it contains rational expressions. 3 over m plus 1 is a rational expression. It is a ratio of a constant 3 and binomial m plus 1. This is a binomial expression because it contains two terms. 1 over m times quantity m plus 1 is a rational expression because it is a ratio of a constant 1 and this binomial m times quantity m plus 1. If you distribute m to m plus 1, that is if you multiply m and 1 by m, you will get m squared plus m, which is a binomial. A binomial is an algebraic expression with two terms. And this equation number 3, k over k plus 2 plus 2 over k squared plus 5k plus 6 equals 5 over k plus 3 is also a rational equation because it is an equation and it contains rational expressions. These two terms at the left-hand side of the equation are rational expressions. The first one is the ratio of a monomial k and binomial k plus 2. The second term is a rational expression. It is a ratio of a constant 2 and this trinomial k squared plus 5k plus 6. And this trinomial, this algebraic expression is said to be quadratic in k because the highest exponent of k is 2 and the variable is k. So this trinomial is said to be quadratic in k. The right hand side is a rational expression because it is a ratio of a constant 5 and the binomial k plus 3. To solve a rational expression, you must first eliminate the denominators by multiplying both sides of the equation by what is known as the lowest common denominator. We solve the first rational equation. Again, the first step in solving a rational equation is to remove the denominators. And to remove the denominators, we find the LCD or lowest common denominator, also known as least common denominator. It is a constant or expression the smallest, the simplest, the smallest expression or quantity that can be divided by all the denominators. To find the LCD of these denominators, we start with the constants and numerical coefficients. The coefficient of y in this denominator is 1. And here the coefficient of y is also 1. And in this constant 1/3, the denominator is 3. So we have 1, 3, 1. 1 is the coefficient of the denominator, the first denominator y. 3 is the denominator of the constant term 1/3. And 1 is the coefficient of the denominator at the right hand side. And you think of the lowest common denominator of 1, 3, 1. The lowest common denominator of 1, 3, 1 is the lowest number, the smallest number that can be divided by all these three numbers, 1, 3, 1. And if you know your multiplication table well, it's very easy. It would be very easy for you to think of the smallest number that can be divided by 1, 3, 1. And that number is 3. Three is the smallest number that can be divided by 1, by 3, and by 1. Exactly, 3 is exactly divisible by 1, 3, and 1. That means if you divide 3 by 1, by 3, and 1, the answer is an integer without a decimal number. Now, 1 cannot be the lowest common denominator for 1, 3, 1 because 1 cannot be divided by 3. After you are done with the numbers, the constants, and the numerical coefficients, you get the LCD of the variables and algebraic expressions in the denominator. All the different variables and expressions that you see in the denominator will be included in the LCD. In this example, there is only one variable that we see in the denominator, which is y. So we take y and multiply it by 3 for our LCD. For example, you see the variable y in the denominators, but one of the y has an exponent of 2. Just supposing that the denominator at the right hand side is y squared. Now you can see that still there is only one variable y that you see in the denominator. So you take y and multiply that by 3 for the LCD. But you will take the highest exponent of y. The exponent of y here is 1, the exponent of y here is 2. And between 1 and 2, the higher exponent is 2. So you write y squared multiplied by 3 for the LCD. Again, if a variable appears in any of the denominators, you take that variable, and if that variable has different exponents in the denominator, you take that variable and take the highest exponent of that variable. Hence, if this is the given rational equation, we take the variable y, because the variable y appears in two denominators, and we take the highest exponent of y, 2. And this is the LCD. Because y squared can be divided by y squared, 1, and y squared can be divided by y. But we go back to the original given rational equation. The exponent of y here is 1. So we take y with exponent of 1. After getting the LCD, you now multiply the left-hand side and the right-hand side by the LCD. We start with the left-hand side, we multiply by the LCD 3y. 3y multiplied by the left hand side 5 over y minus 1 over 3 equals, we also multiply the right hand side by the LCD 3y multiplied by 1 over y. And here we are actually applying the multiplication property of equality, which says that if you multiply both sides of an equation by the same quantity 3y, the equality remains true. For the left-hand side, you now apply property of multiplication over addition or subtraction. That is, you multiply each term of this binomial by 3y. You multiply 3y by 5y. Minus, multiply 3y by 1 over 3. And simplify the right hand side, you can see that y over y will cancel out because y over y is 1. And you get 3 multiplied by 1 is 3. Now simplify the left hand side, 3y multiplied by 5y, you can see you have y over y and that is equal to 1, or you just simply cancel out y. Also, we have 3 multiplied by 1 over 3 in the second term, in this term, and 3 over 3 is 1, or you simply cancel out 3. And you get 3 multiplied by 5 is 15. Minus y multiplied by 1 is y. Equals 3. Hence, using the LCD 3y, we have eliminated the denominators and we get a linear equation in the variable y, from which we can now solve for y by transposing minus y to the right to make the coefficient of y positive 1 and transposing 3 to the left. We transpose minus y to the right hand side, we take the opposite sign of minus y and we get positive y. Positive y equals 15 and positive 3 we transpose to the left hand side and we take the opposite sign of positive 3 and it becomes negative 3 after transposition. Therefore y equals 15 minus 3 is 12. For you to check if your solution is correct, y equals 12 is the solution of this rational equation. For you to check if y equals 12 is a correct solution, you replace y in the given rational equation with 12. We have 5 over 12 minus 1/3 equals 1 over 12. Since we are not yet sure if they are equal, we put a question mark above the equal sign. Now at the left hand side, we get the LCD of 12 and 3. The LCD of 12 and 3 is the smallest, the lowest, the least number that can be divided by 12 and 3. And that number is 12. And we find the numerator by dividing the LCD by each denominator and multiplying the quotient by the numerator. We start with the first term. LCD 12 divided by the denominator 12 is 1. And 1 multiplied by the numerator 5 is 5. Minus 12, LCD 12 divided by the second denominator 3. 12 divided by 3 is 4. And 4 multiplied by the numerator 1 is 4. We want to check if that is equal to, we want to check if this quantity is equal to 1 over 12. And we have 5 minus 4 is 1 over 12. And it's equal to 1 over 12. Thus, we conclude that y equals 12 satisfies the rational equation in number 1. Therefore, this solution y equals 12 is correct. Now, in solving a rational equation, you must take note of the value of the variable in the rational equation that will make the denominator 0. Because if the denominator of a rational expression is 0, then that would be undefined or not defined. And so in the solution, we must exclude those values of the variable in the given rational equation that will make the denominator undefined. For the first rational equation, the only value of y that will make 1 over y or 5 over y undefined, or the only value of y where you will have 0 in the denominator is 0, y equals 0. Now, supposing you solve this equation and you get y equals 0. This value of y equals 0, will make the denominator 0. And so 1 over 0 is undefined. Also, this value of y equals 0 will make this rational expression undefined because 5 over 0 is 0. But when you solve this rational equation, the value that you get is y equals 0. Then you will reject this value of 0. This value of y equals 0 will be rejected, and you will say that y equals 0 is an extraneous solution. Hence, if you get a value of the variable in the process of solving the rational equation that will make the denominator 0 and one of the rational expressions undefined, you reject that value of the variable and you call it extraneous solution. But in solving number 1, the value that we get is 12, and 12 does not make the denominator 0 and the rational expression undefined. It actually satisfies the given rational equation. So y equals 12 is not an extraneous solution. Now we solve number 2. Before we solve the second rational equation, we find those values of the variable m that will make the denominator 0, and so the rational expression undefined. So that when we get these values of m that will make the denominators 0, we will reject them and we will call them extraneous solution. And that's what you do before you begin solving a rational equation. Look for the values of the variable that will make the denominator 0, and so the rational expression undefined. And when you get these values of the variables at the end of the solution, you reject these values and you call them extraneous solution. So we set the denominator, each denominator to 0. We set m times quantity m plus 1 equals 0 because we want to find the values of m that will make this product 0. Also, we set m plus 1 equals 0 because we want to find the value of m that will make the denominator m plus 1 0. And this equation m times quantity m plus 1 is actually a quadratic equation. If you multiply m by m, you get m squared plus m multiplied by 1 is m. So m times m plus 1 equals 0 is actually the quadratic equation m squared plus m equals 0. But this is given in factored form. And in solution of quadratic equation by factoring, after you factor out the quadratic expression, you set each factor to 0. So we set m equals 0. And we set the other factor m plus 1 to 0. And we have m equals 0. And this is now a linear equation in m where we can solve for m by transposing positive 1 to the right hand side. And you will get m equals negative 1. And we have actually solved this linear equation m plus 1 equals 0. That gives us a value of m equals negative 1. Hence, these are the values of m that will make the denominator m plus 1 and m times m plus 1 is 0. When m equals 0, this denominator will become 0. And you get 1 over 0 undefined. Also, when m equals negative 1, this denominator will be 0. M is negative 1 plus 1 is 0. And so 3 over 0 is undefined. Also, this denominator m times m plus 1 will be 0 if m is negative 1. You have negative 1 times negative 1 plus 1. Negative 1 plus 1 is 0 times negative 1 is 0. Thus, 1 over 0 is undefined. These are the values of m that will make the denominator 0 and the rational expression undefined. So we will take note of these values of m so that when we get these values in our solution, we will reject these values and we will call them extraneous solution. Now we solve this equation, this rational equation, by eliminating first the denominators. And to do that, we have to find the LCD or lowest common denominator of the denominators m times m plus 1 and m plus 1. The first term is a constant 2, but if you write its denominator, the denominator of 2 is 1. Again, we start with the constant and the coefficients of the algebraic expressions in the denominators. In the first term, the constant denominator constant is 1. In the second term, the coefficient here of m is 1. And at the right hand side, the coefficient of the denominator m plus 1 is 1. Hence, the denominator of the LCD of 1, 1, 1 is 1. Now we consider all the variables and the algebraic expression in the denominators. You see, I said in getting the LCD of algebraic expressions, take all the variables that you see in the denominator and also take all the algebraic expressions that you see in the denominator. If the variable or the algebraic expression appears more than once in the denominator and with different exponents, you take the highest exponent of the variable, or you take the highest exponent of the algebraic expression that appears in the denominator. The variables that appear in the denominator, there is only one variable that appears in the denominators, and that variable is m, and m appears only one time in the denominators, in the denominator of the second term. So we take m for the LCD. The expression m plus 1 appears in the denominator. So we take the expression binomial m plus 1 and multiply that by m for our LCD. And the highest exponent of m plus 1 is 1. The exponent of m plus 1 here is 1. And you can take this m plus 1 as one quantity raised to the power 1. So we take m plus 1 raised to 1 and multiply that by m for our LCD. Supposing that the exponent of m plus 1 here is 2, you take m plus 1 for the LCD, multiply that by m, but you take the higher exponent of m plus 1. The exponent of m plus 1 here, as I said, if you take m plus 1 as one quantity, the exponent of m plus 1 is 1. Now, m plus 1 appears more than once in the denominators with different exponents, 1 and 2. You take m plus 1 for the LCD, but you take the higher exponent of m plus 1. And between 1 and 2, the higher exponent is 2. So you write here m plus 1 is squared. And we go back to our original rational equation. The exponent of n plus 1 here is 1. The exponent of n plus 1 here is 1. But if the exponent is 1, we do not write anymore the exponent 1. And our LCD is m multiplied by m plus 1 raised to 1, not 2. After you get the LCD, you multiply both sides of the equation by the LCD. That's by multiplication property of equality. You multiply the left-hand side by m times m plus 1. LCD m times m plus 1 multiplied by the left-hand side 2 minus 1 over m times m plus 1 equals, multiply also the right hand side by the LCD m times m plus 1. Multiply by the right hand side 3 For the left-hand side, we apply the distributive property of multiplication over addition or subtraction. That is, we multiply each term of this binomial or this difference by m times m plus 1. We multiply 2 by m times m plus 1 minus, we multiply 1 over m times m plus 1 by the LCD m times m plus 1. For the right hand side, you can see that we have m plus 1 in the numerator and m plus 1 in the denominator. And that will give you 1. So you just simply cancel m plus 1 over m plus 1. So we multiply 2 by m times m plus 1. We multiply 2 by m times m plus 1, we get 2m times m plus 1 minus we multiply 1 over m times m plus 1 by m times m plus 1. The second term is m times m plus 1 multiplied by 1 over m times m plus 1. And the right hand side simplifies to 3m. m times 3 or 3m. For the first term, we again apply the distributive property of multiplication over addition. We multiply 2m by m, and you get 2. Multiply m by m, you apply property of exponent. The common base is m, and you add the exponents of m. 1 here, plus the exponent of m here is 1, and 1 plus 1 is 2. Plus 2m multiplied by 1 is 2m. For the second term, we have m in the numerator and m in the denominator, and that gives you 1. So just cancel out m. You also have m plus 1 in the numerator and m plus 1 in the denominator, and that gives you 1. Or simply cancel m plus 1 and m plus 1. And the second term simplifies to minus 1. Is equal to the right hand side 3m. You can now see from this last equation that we have a quadratic equation in the variable m. This is a quadratic equation because the highest exponent of m is 2. And the variable is m, so this equation is a quadratic equation in m. And we write this quadratic equation in standard form for a quadratic equation. This is the standard form or general form for a quadratic equation. And this is quadratic in x. It's quadratic equation because the highest exponent of the variable is 2 and the variable is x. So this equation is said to be quadratic in x. And this is the general form of quadratic equation with the condition that a is not equal to 0. That is, the coefficient of x squared is not 0. Because if a equals 0, the first term will be eliminated. You have, if a is 0, you will have 0 multiplied by x squared is 0. And what is left is bx plus c equals 0, which is no longer quadratic but linear in x. So it's important that you write the coefficient of x squared a is not equal to 0. So that this term ax squared is retained, and you have a quadratic equation in x. You have an equation where the highest exponent of the variable is 2. So to write this last equation in standard form, one side of the equation, usually the right hand side, must be 0. Therefore, we transpose 3m to the left hand side. And when you do that, you take the opposite sign of 3m. It becomes minus 3m. We have 2m squared plus 2m minus 1. Transpose 3m to the left hand side, minus 3m. Now, nothing is left at the right hand side, equals 0. And we combine like terms or similar terms. 2m and minus 3m are like terms or similar terms. So they can be combined. We have 2m squared. We have 2m minus 3m is minus m. Minus 1 equals 0. We have now written the equation in standard form. This is now a quadratic equation in variable m in standard form or general form. After you have the quadratic equation in standard form or general form, you now solve the quadratic equation. And you can use one of the following methods for solving quadratic equation. You can solve the quadratic equation by factoring if it is factorable. Or you can solve it by completing the square, or you can use the quadratic formula to solve the quadratic equation. Completing the square is not usually used in solving quadratic equation. If the quadratic equation is not factorable, we use quadratic formula. However, the method completing the square was used to derive the quadratic formula. And what are the methods of factoring that you can use to solve this quadratic equation by factoring? You can try common factor. You can check if the quadratic equation, the trinomial at the left-hand side is a perfect trinomial, or whether the trinomial at the left-hand side can be written as a square of binomial. Or you can try the method known as for factoring a quadratic equation, you may use this method to factor out the trinomial at the left-hand side. This stands for trial and error. This method stands for trial and error. If the trinomial at the left-hand side is not a perfect trinomial, it cannot be written as a square of a sum or difference of two terms, then you try to factor this trinomial out by using trial and error. And that's what we will do now. We now factor out the left-hand side of this quadratic equation. That is, we factor out this trinomial 2m squared minus m minus 1 by the method known as TAE or trial and error. We start with the first term, 2m squared. M squared can be factored as 2m multiplied by m. After you factor out the first term of this trinomial, you factor out the constant term. And that's where you will have trial and error. Because the constant term is -1, one of the factors should be positive and the other should be negative. The only factors of 1 are 1 and 1. But one of them should be positive and the other is negative. So the factors of -1 are -1 and +1. The factor -1, you can write it here or write it here. If you write -1 here, then +1 should be added to m. If you write -1 here, then +1 should be added to 2m. And then you check if you will get the middle term minus m. I will write -1 here. I will write m minus 1. And so the other factor of -1, +1 will be added to 2m. Now you check if these are the factors, 2m plus 1 and m minus 1. 2m times m is 2m squared. +1 times -1 is -1. So we get the first and the last terms of the trinomial. Now we check if we will get the middle term. Multiply -1 by 2m. -1 multiplied by 2m is -2m. And m multiplied by 1 is m. Plus m. -2m plus m is negative or minus m, which is the middle term. That means the factors of the trinomial 2m squared minus m minus 1 are 2m plus 1 and m minus 1. Thus, 2m squared minus m minus 1 can now be written as 2m plus 1 multiplied by m minus 1. Equals 0. And in solving quadratic equation, after you have factored out the trinomial, you set each factor to 0 and you solve for the variable. Hence, we set 2m plus 1 to 0. And we solve for m. This is now a linear equation in m. Transpose 1 to the right hand side. You get 2m equals +1 transpose to the right hand side becomes -1. And the coefficient of the variable you are solving for should be +1. So to make the coefficient of m +1, we divide the left hand side by 2. And we divide the right hand side by 2. And 2 over 2 gives you 1, or just simply cancel out 2. And you get m equals -1/2. Now, this value of m is not one of the values of m that will make the denominator 0. The values of m that will make the denominator 0 are 0 and -1. Therefore, we restrict the values of m to those values of m that are not equal to 0 and not equal to -1. And -1/2 is not equal to either one of these. Therefore, we accept this value of m equals -1/2 as a solution. We also equate the other factor m minus 1 to 0 and solve for m. And we simply transpose -1 to the right hand side. It becomes +1. And you get m equals +1. And again, this value of m is not one of the values of m that will make the denominator 0. +1 is not equal to 0, it's not equal to -1. Thus, we accept m equals 1 as a solution of this rational equation. But we now check if these values of m are the correct solutions. We start with -1/2. we replace m with negative 1/2 and we check if the quantity at the left hand side will be equal to the quantity at the right hand side. At the left hand side we have 2. Minus 1 over m negative 1/2 multiplied by negative 1/2 plus 1 you want to check if this quantity is equal to, so we write initially we write a question mark above the equal sign. We want to check if this quantity is equal to 3 over m is negative 1/2 plus 1. Now we simplify this fraction. We have 2 minus 1 over, we have negative times negative is positive. 1/2 multiplied by negative 1/2 plus 1 is 1/2. Or 1/2 or 1 minus 1/2 is 1/2. We want to check if this quantity is equal to 3 over, again you have 1 minus 1/2 is 1/2. And at the left hand side we have 2 plus 1 over 1/2 times 1/2 is 1 over 4. Now we simplify this fraction, multiply 3 by the reciprocal of 1/2. So 3 divided by 1/2 is equal to 3 times the reciprocal of 1/2, 2 over 1. 3 multiplied by reciprocal of 1/2 is 2 over 1. We have 2 plus, again to simplify this fraction, multiply 1 by the reciprocal of 1/4. 1 multiplied by reciprocal of 1/4 is 4 over 1. Equals 3 multiplied by 2 is 6, divided by 1 is 6. And we have 2. 1 multiplied by 4 is 4, divided by 1 is 4. And 2 plus 4 is 6. And it's equal to 6. That means the value of m equals negative 1/2 satisfies the given rational equation. Therefore, this value of m equals negative 1/2 is a correct solution. Now we check if the second value of m equals 1 is also a correct solution by replacing m with 1. We have 2 minus 1 over m is 1, 1 times quantity 1 plus 1 equals 3 over m is 1, 1 plus 1. To simplify the left hand side, we have 2 minus 1. In the denominator, we write a question mark here above the equal sign because we are just checking. In the denominator, we have 1 plus 1. Perform first the operation inside the grouping symbols or the parentheses. 1 plus 1 is 2, multiplied by 1 is 2. is that equal to the quantity at the right hand side. At the right hand side we have 3 over 1 plus 1 is 2, or 3 over 2. Now, to combine, to get the difference of 2 minus 1 half, either you get the LCD of 2 and 1. 1 is the denominator of 2. Okay, we do that. If you write the denominator of 2, the denominator of 2 is 1. And the LCD of 1 and 2 is 2. Now, we find the numerator. 2 divided by 1 is 2. Multiplied by the numerator 2 is 4. Minus 2 divided by 2 is 1. Multiplied by the numerator 1 is 1. And at the left hand side we have 4 minus 1 is 3 over 2, and it's equal to the quantity at the right hand side 3 over 2 is equal to the quantity at the right hand side 3 over 2. Thus this value of m equals 1 is a correct solution of this rational equation. Now, because of lack of time, we will solve this third rational equation in the next lesson. And to solve this equation, we have to factor out this quadratic expression in K. And that's what we will do in the next meeting. But for your practice, please try the following exercises. For your practice, please try to solve the following rational equations. Exercises, solve. Number 1, 1 over 2 plus 1 over x equals 1 over 8. Again, the first step is to find the LCD, lowest common denominator, and multiply the left side and the right hand side of the equation by the LCD to eliminate the denominators. And then we solve the resulting linear equation or quadratic equation. Number 2, we have 1 over 3y minus 2 thirds equals 1 over y. Number 3, we have 3 over x equals 1 over x plus 1 plus 13 over x times quantity x plus 1. In each of these rational equations, you take note of the values of the variables that will make the denominators 0. Like in example 1, in your solution, x cannot be 0, or x should not be equal to 0. Because if x is 0, you get 1 over 0 undefined. Therefore, x equals 0 should not be a solution of this rational equation. And if you get x equals 0 at the end of your solution, then you reject that solution and you say that it is an extraneous solution. In number 4, we are given 1 plus 12 over m equals 12 over m minus 2. In the last rational equation, we are given 1 over x plus x over 2x plus 1 equals 0. And for you to be able to check your answer, I give you the answers. For number 1, the value of x is negative 8 over 3. For number 2, the value of y is negative 1. For number 3, the value of x is 5. Now, this number 3, you check if it has two solutions and if one of them is an extraneous solution. For number 4, the solutions are m equals negative 4 and m equals 6. And for number 5, there is only one solution, x equals negative 1. Again, for each of these rational equation, multiply first the left-hand side and the right-hand side by the lowest common denominator. And that completes our lesson for today. We will have more examples for solving rational equations in the next lesson. But if you have questions about the lesson today, you ask your questions in the comments below. And don't forget to subscribe to my YouTube channel, Art Kalison, the channel of learning and leisure. or you may ask your friends and classmates to subscribe to my YouTube channel, Art Kalison, so they may also learn as well. Thank you for joining me in my class today.